Data science is a very modern term, and it refers mainly to analytics conducted post-digital transformation. Having said that, digital transformation is ongoing, as more industries adopt and embrace data-driven decision-making. This means that data science is an ever-evolving field, at the very forefront of the digital revolution. Methods, software, applications are all highly dynamic, which means people and skills need to adapt rapidly too. We've all heard of the data deluge or information explosion, as companies realise that gathering and storing data is ever cheaper. But making sense of it requires skilled practitioners to efficiently learn from it all. We don't neglect the underlying theory. The methods are constantly evolving, but the framework for measuring performance or comparing multiple approaches remains largely the same. Knowing how to build, assess and compare new methods or algorithms relies on having a deep understanding of data science theory and an appreciation for what's come before. That's why we spend time carefully building upon a solid foundation of a well-established and thoroughly critiqued framework. Our faculty conduct research at the cutting edge of data analytics, working on a diverse range of applications, including finance, genetics, social media, climate, studies of the brain, etc. The trend of increasing sophistication and performance in terms of the ability to handle ever larger datasets will of course continue. However, we're now also seeing some pushback on the idea that big data is any kind of a free lunch. The saying garbage in, garbage out still applies, and no amount of extra data can overcome baked-in biases in data collection. You either need to ensure you gather representative samples, or you need to carefully account for any bias sampling. For example, a Twitter poll usually samples like-minded people, as the poster's followers have similar views and interests, so cannot be directly extended to the general population. Large amounts of easily or cheaply collected data might not be as informative as a smaller amount of carefully collected, more representative data, properly modelled. There will be further diversification of expertise, while top-level data scientists will continue to also maintain a broad skill set. For example, time series have a very particular set of attributes, such as autocorrelation, requiring models and methods that don't come directly from other applications. However, a new algorithm for efficient inference might be quickly and usefully adapted by someone who's a time series specialist but is keeping aware of new developments in other areas. Ongoing professional development is crucial and underemphasized. Data science is developing rapidly, new ideas, new software, new applications. So being a great data scientist in 2022 is a starting point for being a great data scientist in 2023. But you can get left behind quickly if you don't prioritize continuous development. COVID is a great example of the need for ongoing research and constant skill upgrading. The rules of spread and impact evolve rapidly as new variants, new restrictions and new vaccines and treatments interact in ever-changing ways. This means we need to continue to collect new data and develop new models and predictions to meet new challenges. The skilled data scientist is at the forefront of the fight.